Hello, welcome to another video. In this video I'll be going through an A-level paper. This is paper 1, Pure Mathematics 1 of the Specimen papers from Edexcel. These were used as mock papers in 2018. I'll have the paper and the mark scheme linked in the description, and I'll also have the timestamps of each question in case you want to jump to a specific question. Alright, let's get straight into it. Question 1 gives us a graph, and it says figure 1 shows the sketch of the curve with equation y equals x over 1 plus root x, where x is greater than or equal to 0. The finite region R shown shaded in figure 1 is bounded by the curve, the line with equation x equals 1, the x-axis in line with equation x equals 3. The table below shows corresponding values of x and y for y equal to x over 1 plus root x. Here's the table of values. Part A says use the trapezium rule with all the values of y in the table to find an estimate for the area of R, giving your answer to 3 decimal places. Okay, so now I'm not sure if the trapezium rule is in the formula booklet. But anyways, the trapezium rule says the area is equal to half the height of the trapezium multiplied by the y values, so y0 plus 2 lots of y1 plus y2 plus all of the y values up to the second last y value, so yn take 1, and then we add that final y value on the end. Okay, so that's the trapezium rule. The height is the intervals between the x values, so because we're breaking this up into lots of trapezium, this is going to be the height, so h equals a half here for our current question, and then the y values are we just need to input those into the formula and calculate, and we'll be fine. So this is going to equal a half times a half multiplied by y0, which is 0.5, plus 2 times y1, which was 0.6742, plus y2, 0.8284, plus the second last y value, which was 0.9686, and then add the final y value on the end, which was 1.0981. Double check you've got all the values right, and then put that into your calculator, and you get an answer of 1.635125. And the question says round off to 3 decimal places, so this is going to be approximately 1.635. Okay, that was part A. Part B says explain how the trapezium rule can be used to give a better approximation for the area of R. So just add more trapeziums or decrease the width of the strips, or however you want to state that, but basically you're given 1, 2, 3, 4 trapezia for this example, and if you want to get a better approximation, just increase the number of those trapezia, and that'll give you a closer approximation to R. So however you want to state that in your answer for B is fine. Part C says, giving your answer to 3 decimal places in each case, use your answer to part A to deduce an estimate for the integral from 1 to 3 of 5x over 1 plus root x with respect to x. And part 2 says 1 to 3 of 6 plus x on 1 plus root x with respect to x. Okay, so what is this going to do to the graph? That's what you need to figure out. So if we multiply, essentially we're taking this function or this graph here and multiplying it by 5. So let's go up to the graph now. One way to think about this is if you have the graph y equals x, which is just a straight line here, then if you do the graph of y equals 5x, well, you know that that increases the gradient and gets much steeper like that. So for every x value, the y value is now 5 times greater. So you can apply that logic to this curve. For every x value on this curve, the y value is now 5 times higher. So there's going to be a much bigger area under the curve, so it'll be up here like this kind of thing, something like that. So for every value here, it's now 5 times greater. So what have we really done to that area? We've just multiplied it by 5. Okay, so we take that area from A, multiply it by 5 for C part 1. So we can say area from A multiplied by 5 which is 1.635 multiplied by 5. So put that into a calculator. Now you could take your unrounded answer, but in the question it says take your final answer from part A and use it for part C. So we need to just do 1.635 times 5, which is 8.175 as our approximation for the area for part 1. Part 2 says find the integral of 6 plus this function. So if we add 6 onto this, let me just rub this one out quickly. What happens if you add 6 onto a graph? So again, let's look at the example of y equals x and y equals x plus 6. So y equals x is here. If we add 6 onto it, all we do is move it up 6 units. Okay, so now the y-intercept becomes 6. So we can do the same thing for this graph. All we need to do is translate it up 6 units. So now the graph starts at y equals 6, and it'll have exactly the same shape, and we'll end up with something like that. So what does that do to the area? Well, let's draw a straight line at y equals 6. And what would be the area from here down to the x-axis? Well, that would be 6 times 2, right? The area of this rectangle in here would be 12. And then up here we'd have exactly the same area as R. So all we need to do is add on 12 to our answer from part A, which was the approximation of the area of R. So we're adding on 12 for part 2. So we'll do 1.635 plus 12. And that will give us 13.635. Okay, so that was part C for 2 marks and question 1 for a total of 6 marks. Question 2, part A says, show that the binomial expansion of 4 plus 5x to the power of a half in ascending powers of x up to and including the term in x squared is 2 plus 5 on 4x plus kx squared, giving the value of the constant k as a simplified fraction. Okay, so here we're going to have to use the binomial expansion, and that is a formula in your formula book. So firstly, look that up, and then that should be the first thing you write down. So the binomial expansion looks like this. Let me just write out the whole thing. So 1 plus ax to the power n equals 1 plus nax plus n times n take 1 over 2 factorial multiplied by ax squared plus n times n take 1 times n take 2 over 3 factorial multiplied by ax cubed. And this continues into infinity when n is a fraction. Now we're only asked to go up to the x squared term, which is this one here, so we only need to worry about these first 3 terms in this expansion. And we're given the expression 4 plus 5x to the power of a half. Now it needs to be in the form 1 plus ax to the power of n. So we need to do something to this expression so we have 1 plus. So hopefully you see you need to factorize a 4 out of both terms. So we need to do a little bit of work with this expression before we use that binomial expansion formula. So let's write that down here. So we've got 4 plus 5x to the power of a half. And this can be written as 4 multiplied by 1 plus 5 on 4x. And all of that is to the power of a half. And then distribute that power to both terms in those brackets. So because we know that ab to the power of n equals a to the n, b to the n. So using that fact, we'll do 4 to the power of a half, which is the square root of 4, which is 2, multiplied by 1 plus 5 on 4x. And those brackets are raised to the power of 1/2. That's what we end up with here. And in these brackets now, we've got this 1 plus ax. And we can perform the binomial expansion on that part of this expression. So we can ignore that 2 for a minute. We'll have to expand it out through all of the terms afterwards, but for now we'll just focus on these brackets. So we can say that 1 plus 5 on 4x to the power of a half equals, and then we input these values into this expression here. So we start off with 1, and then we've got nax. So n is a half, multiplied by a, which is 5 on 4, multiplied by x. So far so good. Next, we've got n which is a half, multiplied by n take 1. Half take 1 is minus a half. And this is divided by 2 factorial. 2 factorial is just 2, so dividing by 2 is the same as multiplying by a half, so I'm just going to write that as multiplied by a half instead of dividing by 2 there. Then we've got all of this multiplied by ax squared. So 5 on 4 squared, that's 25 on 16. And then we'll also have the x squared term. Okay, so we've got the first 3 terms, and that goes on. So make sure to add the dots there to show that you know that continues, but you're only doing the first 3 terms. Let's simplify this now. So we've got 1 plus a half times 5 on 4. I could simplify that, but I also know that I'll be expanding that 2 out to each term afterwards. So I might just leave that as a half times 5 on 4 x, and then simplify the x squared term. So again, I might leave a half as is. I've got a negative term in here, so this is going to become a negative, a half. And then having a look at the numerators here, 1 times 25, that would be 25. Looking at the denominators, 2 times 2 times 16, that would be 4 times 16, that would be 64. And then we have the x squared. Okay, so we've neatened up that expansion for 1 plus 5 on 4x to the power of a half. Now let's do this for 4 plus 5x to the power of a half. So we know that 4 plus 5x to the power of a half is 2 times this. So we know this is going to equal 2 times this expansion. So all we need to do is multiply each term by 2, and then we should be done. So 2 times 1 is 2. 2 times this, well, I'll just cancel that half out, so we'll have 5 on 4x. 2 times a half here, again, we'll just cancel that half out, so we'll be left with 25 on 64 x squared. Okay, so I hope you followed along with that. We've got to our final expansion, and going back to the question to make sure I've answered all of it, we've got a k here of negative 25 on 64. So just checking, we had a 2 plus 5 on 4x. Yes, that's correct. And then k would equal negative 25 on 64. Okay, that should all be fine. Part B says, use the expansion from part A with x equal to 1 over 10 to find an approximate value for root 2. Give your answer in the form p over q, where p and q are integers. Okay, so let's take our answer from part A. We can approximate when x equals 1 on 10, the value of root 2. So when x equals 1 on 10, well, let's substitute it into this expansion. I would start by writing that expression first, 4 plus 5x to the power of a half equals 2 plus 5 on 4. And then when we get to x here, we need to substitute 1 on 10 in. Okay, so this is going to be minus 25 on 64 times 1 on 10 squared, which is 100. Okay, let's try to simplify this now. So that 100 there will cancel with this 25. We'll have 1 on 4. And this 10 here in the denominator would cancel with this 5. So that would become 1 over 2. So then we're left with 2 plus 1 on 8, 4 times 2. And then 1 on 4 times 64. 4 times 64, if you know your powers of 2, you'll know that's 1 over 256. Once I got to this stage, I'd probably just put that into a calculator. So 2 plus 1 on 8, take 1 on 256, and then make sure you put it back as a fraction. We get 543 over 256. Okay, so now what happens to this expression when we substitute 1 on 10 into it? This would become 4 plus 5 times 1 on 10. That would be the same as a half to the power of a half. And let's keep going with that. So 4.5 can also be written as 9 on 2 to the power of a half. And this was equal to 543 over 256. Then raise both of those terms to the power of a half. So then we'd have the square root of 9 over the square root of 2. The square root of 9 is 3 over root 2 equals 543 over 256. And so to get approximation to root 2, we just need to rearrange this so that root 2 is the subject. So we'll have root 2 equal to, now if we rearrange this, we would probably multiply by root 2 over here. Essentially just have to flip everything around. So then we'll have 256 on 543 multiplied by 3. So that will cancel out. So we'll have 181 on the bottom line and 256 on the top line. So our approximation for root 2 is 256 over 181. Now, you can also write 3 on root 2 slightly differently because 1 on root 2 is also equal to root 2 on 2. Those two things are equivalent, so using that idea, you can also write this as 3 on root 2 is equal to 3 root 2 on 2. So then you get a different equivalent fraction to this. So it would be 181 on 128. So there are two equivalent fractions as answers to this question. So just going back to the question again, we've given it in the form P over Q, where they're both integers. Part 2 says explain why substituting x equals 1 over 10 into the binomial expansion leads to a valid approximation. Okay, so we're talking about validity here. So we performed a binomial expansion on the expression 1 plus 5 on 4x to the power of a half. And the general idea of the binomial expansion approximating the value of this expression is based on convergence. So we want it to converge to a particular value when we do that expansion. And it's generally thought that when this power is a fraction, this generally only happens when ax is between -1 and 1. I don't believe this is proven to always be the case, but I think it's more of a general rule that if ax is between -1 and 1, this will converge to a particular value and then the expansion is valid. So this is the typically accepted test of validity. So we have an ax of 5 on 4x, so 5 on 4x needs to be between 1 and -1. And we want x by itself, so multiplied by 4 divided by 5, we'll have x between -4 on 5 and 4 on 5. And we have an x of 1 over 10, which is between these two values, so we can say therefore x equals 10 is a valid x value. So is a valid x value for an approximation. Okay, going back to the question, that was part B for 4 marks and part A was 4 marks, so question 2 in total was 8 marks. Question 3 says a sequence of numbers a1, a2, a3, etc. is defined by a1 equals 3, an plus 1 equals an minus 3 over an minus 2, where n is belonging to the natural numbers. Part A says find the sum of the first 100 terms, so that's what that notation means. Starting at a1, we go up to a100. My advice would be if you ever get a question where the expression is not a geometric sequence or an arithmetic sequence, just try to figure out the first few terms of the sequence, then maybe you'll see a pattern, and then you can go from there. The other clue is this is only a 4-mark question, so it probably doesn't involve any in-depth proof. So let's start with n here being 1, 2, 3, 4, 5. Let's go up to 5 to start with. And then we'll work out what a sub n is. So they've told us a sub 1 is 3. A sub 2 will be 3 take 3 over 3 take 2. This would be 0. 3 take 3 is 0. So 0 divided by anything, 0. Next one would be 0 take 3 over 0 take 2. This would be 3 over 2. We'll have -3 over -2, so those negatives cancel out. Next we'd have 3 on 2 take 3 over 3 on 2 take 2. If you think of this as 1.5 take 3, that would be -1.5 or -3 on 2. 1.5 take 2, that's -0.5. If we take these two fractions, well, how do you divide fractions? You flip and multiply. So if I flip these and multiplied them, this would be -3 on 2 multiplied by -2 on 1. Those 2's would cancel out there. Also, the two negatives become a positive, and we've got 3. So the fourth term is 3. And then you notice, well, this sequence is going to keep repeating. So the fifth term, we would get the same as the second term. It would be 0. So 6 would be 3 on 2, 7 would be 3, etc. Okay, so this sequence is repeating after the first 3 terms. So every 3 terms the sequence repeats, and if we were to go up to 100, that would repeat, well, think of 100 divided by 3. Well, it doesn't go in evenly, but 99 divided by 3 is 33. So it'd be 33 of these repetitions up to 100. And then what would we get next? We'd get a 3. So the 99th term would be 3 on 2, and then the 100th term would be 3. So if we want to figure out this sum of the first 100 terms, we can use the factor repeats to figure that out. So for part A, let's write out that notation. Starting at 1, going to 100, the sum of the first 100 terms. As I said, we'll have 33 of each of these terms. So 33 times 3 plus 33 times 0, well, that's just going to be 0. And then 33 times 3 on 2 plus that 100th term, which would be a 3. Then we just need to figure out the sum of this. So 33 times 3, that's 99. 33 times 3 on 2, or 1.5, that's 49.5 plus 3. This is going to be 148.5 plus 3, that will be 151.5. Okay, that was part A. Part B says, hence find the sum of the first 100 terms plus the sum of the first 99 terms. Okay, so what we'd have is just this bit. So this is the first 99 terms without that plus 3 added on the end. Remember, that was the 100th term. So we could say that this is just going to be this bit plus 151.5. So let's write that out. So the sum of the first 100 terms plus the sum of the first 99 terms equals 151.5 plus 99 plus 49.5, which was 148.5. 51.5 plus 48.5, that's 100, so this is going to be 300. Okay, so that was part B for 1 mark and a total of 4 marks for question 3. Question 4 says, relative to a fixed origin O, the point A has position vector I plus 7j minus 2k, the point B has position vector 4i plus 3j plus 3k, and the point C has position vector 2i plus 10j plus 9k. Given that ABCD is a parallelogram, find the position of vector point D, which is part A. Okay, just to quickly illustrate what they mean by position vector, so I'll just draw a quick sketch of what's going on here. So we have an origin O, and we have 4 points A, B, C, and D, and they form a parallelogram. So if we were to draw a parallelogram, now I don't know if this is what it would look like, but this is the general idea. So the position vector is the vector from the origin O to A. So if we were to draw a vector from O to A, that would be the vector I plus 7j minus 2k. Similarly for B, we'd have a vector going from the origin to B, being 4i plus 3j plus 3k. Same for C, and then they're asking us to find the position vector of D, which would be this one here, going from the origin to D. Okay, so from this illustration, how can we use our existing vectors to get to D? Well, one way would be to use the vector OC from the origin to C, and then go from C to D. Now, because this is a parallelogram, this side will be equivalent to this side of the parallelogram. And this side I can find using the A and B vectors. So this side here, from A to B, I could do negative B plus A to get from B to A. So all up, to get from the origin to D, I could go OC plus BA. So this is going to be the vector BA here. All right, so I'm going to use that idea to find the position vector of point D. So let me just state my reasoning here. The position vector OD is going to equal OC plus the vector BA, Or you could do that the other way around. You could take the vector AB. So the vector BA equals, as I said before, this would be negative OB plus OA. So therefore, the vector OD equals OC plus negative OB plus OA. Okay, now we have these already given to us. I might do this in column vector form. So to write these as column vectors, we just take the coefficients of I, J, and K, write them as a column vector. So we've got the vector OC, which is 2, 10, 9, plus the negative of OB. Now OB was 4, 3, 3, so they are all negatives. 4, 3, 3. Negatives of all those, plus OA, and A was 1, 7, minus 2. Okay, so now to add column vectors, all we do is just add the numbers. So this is going to be 2 plus minus 4, or 2 take 4 plus 1. Negative 2 plus 1 is negative 1. 10 take 3 plus 7, that's 14. 9 take 3 take 2, that will be 4. And then let's write this in terms of the unit vectors. So OD is going to be negative I plus 14J plus 4K. Okay, so that is the position vector of D. Part B says the vector AX has the same direction as the vector AB. Given that the magnitude of AX equals 10 root 2, find the position vector of X. Okay, so again on my diagram, I'll just neaten this up a little bit. So on my diagram, let's have a look at where X could be. The vector AX must start at A, and it has the same direction as AB. So X is going to be on this line somewhere from A to B. Or X could be further out, but it needs to be in this same direction. So either on this line somewhere between A and B or past B. And we need to find the position vector of X. So from O to X, which would be this line here. Okay. What you could start with is to find the magnitude of AB. So find the length of AB, and maybe that will help you in relation to AX. So maybe you'll find that it's half of AX or double AX, and then that'll help you to find X. Okay, so we need the magnitude of the vector AB for part B. And to figure that out, we take the square root of the vector AB. And well, we've already kind of figured out AB. We said that BA was this. And it doesn't really matter if you write it BA or AB, it'll still have the same magnitude. So if we figure this out by itself, this would be negative 4 plus 1, negative 3. Negative 3 plus 7 would be 4, and negative 3 take 2 would be negative 5. Okay, so that's the vector BA. Again, swap it around, it would just be 3, negative 4, 5. And when we're figuring out the magnitude, it doesn't matter what these signs are because we're squaring them. So the magnitude of AB is going to be 3 squared plus 4 squared plus 5 squared. And I talked about this in a previous video. You're basically looking at the diagonal of a cuboid. That's how you're finding the magnitude of a vector in 3-dimensional space. And let's go ahead and figure this out. 3 squared plus 4 squared, that's 25. 5 squared is 25, so this is going to be the square root of 50. And then this can be written as the square root of 25 times the square root of 2. The square root of 25 is 5. So the square root of 50 can be written as 5 root 2. And let's have a look at the magnitude of AX. That was 10 root 2. So we can clearly see that the magnitude of AX is twice the magnitude of AB. So let's state that now. So therefore, the vector AX is going to be 2 times the vector AB because they're going in the same direction. So all we need to do now is to say AX equals 2 times the vector AB. And we figured that out before. That was 3, negative 4, 5. I'm just reversing those because we're going the other way. So 3, negative 4, 5. And this would equal 6, negative 8, 10. Okay. Again, I've just multiplied the vector AB by 2, which means you just multiplied 2 by all of the terms in the vector. So now we have the vector AX. Going back to the diagram again, we've got this vector, and now we know that X is not between A and B, it's past B. So how can I get from the origin to X? Well, I could go from OA to AX. Now I know both of those vectors, so if I add those together, I'll have OX. Okay, hope that makes sense. So we're doing the vector OX is going to equal OA plus AX. And I might just bring that down to the next page. Now OA was 1, 7, negative 2. AX, we just figured out, was 6, negative 8, 10. This one we just figured out. So now we just need to add those together. So it's going to be 1 plus 6 is 7. 7 take 8, negative 1. And negative 2 plus 10 is positive 8. And then let's just write that in terms of the unit vectors. So this is going to be 7i take j plus 8k. And we're done. So let's just double check. Find the position vector of x. We've done that. And that was question 4 for a total of 5 marks. Question 5 says f of x equals x cubed plus ax squared minus ax plus 48, where a is a constant. Given that f of minus 6 equals 0, part A1 says show that a equals 4, and 2 says express f of x as a product of two algebraic factors. Okay, so if f of minus 6 equals 0, that means x plus 6 is a root. Okay, so we'll start off with that fact. So let's start A down here. And what I usually like to do is to rewrite the function out again. Partly it gives me something to do while I'm thinking about the question. Partly it stops me from having to go up to the top of the question every time to check what I'm meant to be doing. So that's the function there, and then they've given us the fact that f of minus 6 equals 0. So therefore what that tells us is that when we substitute negative 6 into this expression, then we can set it equal to 0. So negative 6 cubed, 6 cubed is 216, so this would be negative 216, plus ax squared, 6 squared is 36, so this would be 36a. Take ax, well this would become a positive because x is negative. This will be positive 6a, and then plus 48, and set that all equal to 0. And that's going to allow us to solve for a. So negative 216 plus 48. 216 take 48, that's 168. So this is going to be negative 168. 36 plus 6 is plus 42. A equals 0. So therefore 42a equals 168. So therefore a is going to be 168 divided by 42. If you do that calculation, you get 4. So there a equals 4. And part 2 was express it as a product of two algebraic fractions. Again, if f of minus 6 equals 0, then x plus 6 is a factor. So think of a quadratic equation. When you factor it, like say you had a quadratic like x plus 2, x plus 3 equals 0, then you know that x equals negative 2 or x equals negative 3. So using that same idea, we can say x plus 6 is a factor. Therefore, we can say that f of x equals x plus 6 multiplied by some quadratic. So because we're starting with a cubic, so we must have some quadratic here as the rest of the expression. And we already know what the first term must be because the coefficient of x cubed here is 1. So therefore the coefficient of this x squared term must be 1. So we've got the x squared term. Also, we need 6 times something to equal 48. Therefore, we know the final term in this quadratic must be 8. And we just need to figure out the middle term here. So we could just put some variable in. Let's call that bx. And then we could expand this out and work out what b is. So this is equal to x cubed plus bx squared plus 8x plus 6x squared plus 6bx plus 48. Now you could use the x squared terms here. So the x squared term in our original expression is a, and a was 4. So they need to add to 4. So b plus 6 needs to equal 4. So then therefore b must equal -2. Okay, so this is going to equal x plus 6 multiplied by x squared take 2x. Main issue there was finding that middle term in that quadratic. Okay, so we get x plus 6 multiplied by x squared take 2x plus 8. So we have expressed f of x as a product of two algebraic factors. Part B says given that 2 log base 2 of x plus 2 plus log base 2 of x take log base 2 of x take 6 equals 3, show that x cubed plus 4x squared take 4x plus 48 equals 0. Okay, so let's start off with this expression, see if we can simplify that. So I'm going to rewrite that down below. So starting off with b here. Alright, if we use our log laws, we'll be able to simplify this quite a bit. So the log laws I'll be using are the log of a plus the log of b equals the log of a times b, and the log of a take the log of b equals the log of a over b. Also, a log b equals the log of b to the power a. Using those three laws, firstly, we can rewrite this first term as the log base 2 of x plus 2 all squared. Then because I'm adding these logs, I've got the same base. I can rewrite this as the log of x plus 2 times x, or x plus 2 squared times x. And then because I'm subtracting another log again with the same base, I can divide this by the term in this log. So this will be all divided by x take 6, and this is equal to 3. Okay, so I've neatened it up a bit. Now if I raise both of these terms to the power of 2, I'll be able to get rid of this log. This is another law of logs, so if I have the log base 10 of x, and that's equal to 1, then I can raise both to the power of 10. Log base 10 of x equals 10 to the power 1, and that log will cancel out, so I just get x equal to 10. And that makes sense, right? Remember, the log is asking what is the power of this number. So if the log of log base 10 of x is 1, then x must be 10. So raise both of these to the power 2. That log base 2 will cancel out. We'll just be left with x plus 2 squared times x over x take 6 equals 2 to the power 3. If you go from this step to this step, you might want to explain what you've done. Raised to the power 2. And now we can try to simplify this. So 2 cubed is 8. Multiply the right hand side by x takes 6. On the left we'll be left with x plus 2 all squared times x equals 8 times x takes 6. Simplify, so expand the brackets. X plus 2 all squared, that's x squared plus 4x plus 4 times x equals 8x take 48. Expand that x out to all of the terms in those brackets. We'll have x cubed plus 4x squared plus 4x, and then subtract both of these terms from the left hand side. So we'd have take 8x plus 48, and that will all equal 0. Simplify, so all we need to do is to do 4x take 8x. So this is going to be x cubed plus 4x squared take 4x plus 48 equals 0. Plus 4 take 8 is -4. Therefore, we've shown that if we start with this expression, we can simplify it to this cubic here. Okay, so that was part B. Part C says, hence explain why 2 log base 2 yada yada yada, all of that, has no real roots. Okay, so we're going to have to connect these facts somehow. Now, of course, you notice that this expression is the same as the function we started with, and we've already factorized that into these factors here. So we can say that if we start with this expression, then we end up with this factorized cubic here. So let's just state that firstly. So if, and rewrite out all of that again. So if we have this equation, then we can also say that x cubed plus 4x squared take 4x plus 48 equals 0, as shown in part B. And therefore, we've also shown that this equals x plus 6 multiplied by x squared take 2x plus 8. And that is equal to 0. Okay, so now we also need to find the factors of this quadratic to get all of the solutions to this equation. So we know x equals minus 6. So we can't factorize this quadratic. So we'll have to use the quadratic formula, which is minus b plus or minus the square root of b squared take 4ac over 2a. And so let's plug in all of the values. B is negative 2, so this is going to be 2 plus or minus b squared, which is 4, take 4 times a, which is 1, times c, which is 8, over 2 times a, which is just 2. And now you'll see this determinant here is actually going to be a negative. So we could say that the square root of b squared take 4ac equals 4 take 32, which is negative 28. So this is the square root of negative 28. That means we don't have any real solutions for this quadratic. So these are going to be complex numbers. So the only real solution is x minus 6. So we'll say, therefore, the only real solution is x equal to negative 6. And we know that the log function is undefined when x is less than 0. Now, it's not this x. We'd have to plug this into this function. If we had negative 6 plus 2, we'd have log base 2 of negative 4. So that would be undefined. Log of x, well, that would just be log of minus x. And then the log of minus 6 take 6, that'd be a negative as well. So the next thing we need to state is log of x is undefined when x is less than 0. So for x equal to negative 6, terms in our equation are undefined. So therefore, there are no real roots. Okay, that was question 5 for 10 marks. Let's just go back to the marks. So we had 4 marks for part A, 4 marks for part B, and 2 marks for part C. Question 6 says, figure 2 shows the entrance to a road tunnel. The maximum height of the tunnel is measured as 5 meters, and the width of the base of the tunnel is measured as 6 meters. Figure 3 shows a quadratic curve BCA used to model this entrance. The points A, O, B, and C are assumed to lie in the same vertical plane, and the ground AOB is assumed to be horizontal. Part A says find an equation for the curve BCA. Okay, so they've given us the height and the width of this quadratic. They've said this is 6 meters wide and 5 meters high. So we know that the y-intercept of this curve is going to be at 0, 5. And that the roots, or the x-intercepts, are going to be, well, if it's 6 meters wide, then each of these is 3 meters away from the y-axis. So it's going to be negative 3, 0, and 3, 0. And all of that helps us in making our equation for this quadratic. So we can start off with the general form of a quadratic. Now typically a quadratic will be written as ax squared plus bx plus c, where a, b, and c are some constants that you will need to work out. However, when a quadratic has its axis of symmetry as the y-axis, there is no x term, so we can kind of ignore that. And we also know that c is the y-intercept. So we already know that this is going to be y equals ax squared plus 5, because as I said before, this x term is how far the graph is translated left or right away from the y-axis. So I'm going to write some of that information down. So firstly, the y-intercept. It's always good to be clear about what you know from the question. Is 0, 5. So therefore, y equals ax squared plus 5. And also we can use any of the points on that curve really to plug into this equation and then find a. So we could use one of the x-intercepts. So let's say using 3, 0. Plug them into this equation. 0 equals a times 3 squared plus 5. And then a is going to equal, take that 5 from the left-hand side, negative 5, and then 3 squared is 9. So we'll divide this by 9 and we'll get a equal to negative 5 over 9. So therefore, put that a back into this equation. Therefore, y is going to equal negative 5 over 9, x squared plus 5. Now there's another way you could do this. You could say that this graph is going to equal y equals some coefficient multiplied by the solutions of the equation, which are the x-intercepts or the roots of the equation. So this is going to be x take 3 and then x plus 3, because negative 3 and 3 are the two solutions, and then you can work it out that way. So it's all pretty much the same thing. However you want to state that quadratic in the beginning is fine, and then as long as you understand that you need to use one of those points to put into the equation to find a, the coefficient, then you should be fine. Okay, so that was part A for 3 marks. Part B says a coach has height 4.1 meters and width 2.4 meters. Determine whether or not it is possible for the coach to enter the tunnel. Okay, so if it has a width of 2.4 meters, then the x value, so the middle of the coach would be on the y-intercept, then the x value is going to be half of that, right? So there will also be 1 over here. So that entire width needs to be 2.4, but the x value here will only be 1.2. Well, it won't be 0, it'll be some y value we need to find. So we know the x value. If the width is 2.4 meters, we can go ahead and find the y value, and if it is higher than 4.1 meters, then we can kind of assume that the coach should be okay passing through the tunnel. Okay, so for part B, x equals 1.2. So take the equation you found in part A. So therefore we know that y equals negative 5 on 9 multiplied by, now instead of using 1.2 here, I might use 6 over 5, just because I find that easier to square and work with. So this is going to be 6 over 5 squared plus 5. 6 over 5 squared, that's going to be 36 on 25 plus 5, and then work with these numbers here. So cancel that 25 with the 5 in the numerator. That'll cancel to 1. This will be 5. And that 9 and that 36, they can cancel because 9 goes into 36 4 times. So this will end up being 4 over 5, or negative 4 over 5. So we get negative 4 over 5 plus 5. That's like negative 0.8 plus 5. So this is going to be 4.2 meters. So if the width of the coach is 2.5 meters, then the height on our quadratic here is going to be 4.2, which is just high enough for the coach to pass through. So we can say, yes, the coach will be able to pass through. So I might say something like the tunnel is higher than the coach at the required width. Okay, so that was part B. Part C says, suggest a reason why this model may not be suitable or to determine whether or not the coach can pass through the tunnel. So here you just need to kind of use your common sense. So if you're looking at a tunnel, it might not exactly fit the quadratic curve. The tunnel might not be uniform all the way through. The ground might not be perfectly level, might not be perfectly horizontal. The tracks might not be exactly in the center of the tunnel. There's all sorts of reasons you could give. So you could give any one of those. for that 1 mark. So here I'll just write down a few. So perhaps the tunnel is not uniform, perhaps the ground is not level, or maybe it's not centered in the tunnel. The other thing is that, what about a train coming from the other direction? You don't know the entrance to the other side of the tunnel. Maybe that would make a difference as well. But that was part C, and all up, question 6 was for 6 marks, 3 marks for part A, 2 marks for part B, and 1 mark for part C. Question 7 gives us a graph, and it says figure 4 shows a sketch of the curve with equation y equals 2e to the power of 2x. Take x e to the power of 2x, where x is any real number. The finite region R shown shaded in figure 4 is bounded by the curve, the x-axis and the y-axis. Use calculus to show the exact area of R can be written in the form p e to the power 4 plus q, where p and q are rational constants to be found, and solutions based entirely on graphical or numerical methods are not acceptable. Well, they already told us we had to use calculus, so that's effectively saying the same thing. But let's go ahead and get started on this. So firstly, we'll have to find the integral of this graph. And looking at this equation, 2e to the 2x shouldn't be too hard to integrate, but x e to the power of 2x, we'll have to use integration by parts for that, because we have the product of two functions in one term. Okay, so I might start with integrating that term because I feel that's going to be the hardest part of the question. And once I get that sorted out, everything else from there should be pretty smooth sailing. So let's start off with the integration of x e to the power of 2x. Okay, and I might just leave the negative off of this for now and introduce it later. So this is going to equal, now let's think about which term we want to be u and which term we want to be dv. Remember, integration by parts, the rule for this is that the integral of u dv equals uv, take the integral of v du. And you need to let one of these terms equal u and one equal the derivative of v. And generally, as a rule of thumb, you want dv to be the term you think will be easiest to take the integral of, or that will lead to less complications when you take the integral. So I'm going to start with u equal to x and dv, the derivative of v, equal to e to the power 2x. Because I know the antiderivative of e to the 2x is just half e to the 2x, so I don't introduce any new variables, whereas the integral of x is going to be x squared on 2. So that brings in an x squared term that I don't think I'll really want to deal with. So that's where I'm starting off. Then we'll work out the derivative of u is just 1. So hopefully that won't introduce any new complications. And then v, as I said, the integral of e to the 2x is half e to the 2x. And the reason for this is mainly due to the reverse. So if we take the derivative of v here, we need to end up with e to the 2x. How do we do that? Well, if we're taking the derivative of v, we'd use the chain rule. That 2 would come down the front, cancel with that half, and we'd end up with e to the 2x. So we can reverse that to get the integral. So now we have du and v. We can use this formula to work out what the integral of x e to the 2x is. So u is x, v is a half e to the 2x, and then we need to subtract the integral of v, which is a half e to the 2x, multiplied by du, which is just 1. Okay, so I don't need to write that in. Okay, so this will actually be simpler, this integral, because all I have is an e to the 2x. I don't have any x term. So let's keep working with this. I'll write this first term as a half x e to the 2x, and then the integral of a half e to the 2x. Well, if the integral of e to the 2x is half e to the 2x, then the integral of this is going to be a half e to the 2x again. This is going to turn into a half times a half e to the 2x, which will be a quarter e to the 2x. Okay, and then always remember to plus the C on the end. Okay, so now we have we've used integration by parts to get the integral of that part of the expression, and I feel that will be the hard part over. So to find this area R, we also need where this area starts and ends. So I know it starts at 0, but I also need the x value for where the graph crosses the x-axis. So one way I could do that is to find the solutions of this equation. So let's say we're looking for the root or the roots of this equation. So let's start off with 2e to the 2x, take x times e to the 2x equals 0. That's where we're going to find where it cuts the x-axis, where y equals 0, and then factorize the e to the 2x out, so therefore e to the 2x multiplied by 2 take x equals 0. So therefore e to the 2x equals 0, or 2 take x equals 0, therefore x equals 2. 2 take 2 is 0. For this one, it won't have any real solutions, and anyways, we don't need to really worry about it. E to the power of anything can't be 0. So, alright, so we have the root x equals 2. So we can say the area is from x equals 0 to x equals 2. And now we're looking for the definite integral from 0 to 2 of this equation here, this graph. So let's start this down here on the next page. So we're looking for the integral from 0 to 2 of 2e to the 2x, subtract x e to the 2x with respect to x. Okay, so starting with this first term, 2e to the 2x. Now we've already said the integral of e to the 2x is a half e to the 2x. So if I multiply that by 2, all I'll be left with is e to the 2x. And we've already integrated this, minus x e to the 2x, or well, we left the negative off, so we'll have to introduce that back into the expression here. So we've got half x e to the 2x, take a quarter e to the 2x. So let's put that in now, and we have to introduce that negative back, as I said. So this is going to be a half x e to the 2x, take a quarter e to the 2x. Okay, and that's from 0 to 2. All right, now according to the fundamental theorem of calculus, we can substitute 2 into this, subtract this expression when we substitute 0 in, and that'll give us the area R. Okay, so for the first substitution, we'll have e to the 2 times 2, which is e to the power 4. Take a half times 2, which will just be 1. E to the 2x, again, will be e to the power 4. Plus, because I've distributed that negative to this term, so it will turn into a plus, this will be a quarter times e to the power 4. Okay, so that's our first substitution. Then we need to subtract and substitute in the 0. E to the 2 times 0 will be e to the 0, which is just 1. Subtract a half times 0. This term will just be 0. And then the last term will be plus a quarter e to the power 0. So that will be 1 multiplied by a quarter, which will just be plus a quarter. All right, so now we've done all the substitutions, and we can just simplify this and hopefully end up with an expression that they were looking for. Okay, so looking at this first set of brackets here, I can see we've got an e to the power 4 take e to the power 4, so they'll cancel out. Then I'm left with a quarter e to the power 4. Subtract 1 plus a quarter, well, that's just going to be 1 1/4 or 5 over 4. And that's a positive, so this will be take 5 over 4. And then essentially we're done. So let's go ahead and check if we got the form they were looking for. So we're looking for p e to the power 4 plus q. So in our expression, p would be a quarter and q would be negative 5 over 4. So that looks good, and I think I'd be confident with that answer in an exam situation. Okay, so that was question 7 for 5 marks. Question 8 says there were 2,100 tons of wheat harvested on a farm during 2017. the mass of wheat harvested during each subsequent year is expected to increase by 1.2% per year. Part A says find the total mass of wheat expected to be harvested from 2017 to 2030 inclusive, giving your answer to 3 significant figures. So if we start with a certain amount and we multiply that amount by the same thing each time, what sort of sequence do we call that? We call that a geometric sequence. So to start off, to increase something by 1.2%, we'd multiply 2,100 by 1.012 to get the next year. And then we'd do the same thing the year after that, multiply by 1.012. And we're multiplying by the same thing. And so it's a geometric sequence. How do we find the sum of a geometric sequence? We need to use the sum formula. So for part A, that's what I'd start off by writing down. So the sum of n terms in a geometric sequence is equal to the first term, a1, multiplied by 1 take r to the power n. R is what you're multiplying by, essentially. The reason it's r is they refer to it as the ratio between each term, the common ratio. So it's what you're multiplying by, and that's divided by 1 take r. Okay, so we've got a1 in the question. They tell us that's 2,100. The thing we're multiplying by is 1.012 to increase by 1.2%. And how many terms are we looking for here? So we're going from 2017 to 2030 inclusive. So it's not just up to 2030, it's also including 2030. That means it won't be 13, it will be 14 years, or 14 terms we're looking for. So n equals 14. Once you have all of that information, all we really need to do is to substitute it in. So the sum of 14 years is going to be 2,100 multiplied by 1 take 1.012 to the power of 14. And that is all divided by 1 take 1.012. Okay, and then we could go ahead and put that into a calculator. So on the top line, we've got 2,100 multiplied by 1 take 1.012 to the power of 14, and that is all divided by 1 take 1.012. And you should get an answer of 31,806.9948. So I'd probably write that down first before you do any rounding. So this is going to be 31,806.9948. And then go back to the question and check. So it says to 3 significant figures, so we need to round this off to 31,800, and that is in tons. Okay, so that's part A. Part B says each year it costs £5.15 per tonne to harvest the first 2,000 tonnes of wheat, and £6.45 per tonne to harvest wheat in excess of 2,000 tonnes. Use this information to find the expected cost of halving the wheat from 2017 to 2030 inclusive. Give your answer to the nearest £1,000. Okay, so if we have 2,000 tonnes per harvest for 14 years, that will give us 28,000 tonnes at £5.15. And then whatever we have left over will be at £6.45. So I'll go ahead and write some of that working out down. So we've got 2,000 times 14 tonnes, which is 28,000 tonnes at that lower price. And then what have we got left over? Well, 31,800 take 28,000. That will be 3,800 tonnes at the higher price. £6.45. Okay, so now we just need to do the multiplications, add them together, and we'll have our price. So the total cost is going to be 28,000 times 5.15 plus 3,800 times 6.45. Put that into a calculator, and we get a total of 168,710. And we need to round that off to the nearest 1,000. So 8 is going to round up to 9. So this is going to be approximately £169,000. Okay, so back to the marks. That was worth 3 marks. Part A was only worth 2 marks. And question 8 was a total of 5 marks. Question 9 says the curve C has equation y equals 2x cubed plus 5. The curve C passes through the point P at 1, 7. Use differentiation from first principles to find the value of the gradient of the tangent to C at P. Okay, so whenever you see first principles, you can think of this formula. So the derivative of y with respect to x will equal the limit as h approaches 0 of f of x plus h, take f of x all over h. And that's actually in your A-level formula booklet under first principles. Okay, so let's go ahead and substitute things into this. So always write your limit. Now when we've got x plus h as the input, we'll have x plus h cubed here. So we're putting that in to this expression where x is. So this is going to be 2x plus h cubed plus 5. And then we subtract the function as it is. So it'll be just 2x cubed plus 5 in there. And that's all over h. And now again, writing the limit, we need to expand out those brackets there, the cubed brackets. Now there's a kind of a shortcut you can do when you've got two variables. It's slightly easier than if one of them is a constant or if you have a coefficient. But we don't have any coefficients here. So we can just write that as x cubed plus 3x squared h plus 3x h squared plus h cubed plus 5. And this is subtract 2x cubed, take 5. So remember to distribute that negative to both terms. And that's all over h. And now we should probably expand those brackets out with that 2 there. So this is going to be 2x cubed plus 6x squared plus 6x squared h plus 6h x squared plus 2h cubed plus 5 take 5. They would cancel out and we'd just be left with take x cubed. And that's all over h again. Alright, so let's see if we can simplify this any further. We've got a 2x cubed here and a subtract 2x cubed on the end. They will cancel out. Then we're left with these three terms. They all have a h in them, so I'll factorize out a h in my next line. So this is going to be the limit as h approaches 0 of h multiplied by 6x squared plus 6xh plus 2h squared all over h. And then those h's will cancel out. So we'll just be left with what's inside the brackets. So we can write this as the limit of 6x squared plus 6hx plus 2h squared. And remember, the whole point of this is to assume that h is approaching 0. So when it's really close to 0, we can effectively assume these two terms will be 0. So therefore we can say dy and dx is going to equal 6x squared. And so we have the derivative from first principles, and it was asking us to find the gradient of the tangent at P. So the gradient of the tangent is the derivative. So we can say when x equals 1, that should give us the gradient of the tangent at P. And let's just check 6x squared is correct. So if we were to take the derivative of 2x cubed, we'd use the power rule. So we'd bring that 3 down the front, multiply it by 2, we'd get 6, and then we'd subtract 1 from the power. So we should get 6x squared. So we can see we didn't make any mistakes in our working there. So let's go ahead and say when x equals 1, dy on dx equals 6 times 1, which will just be 6. So therefore we can say the gradient at P equals 6. And so we've answered the question and we're done. And that was question 9 for 5 marks. Question 10 says the function f is defined by f of x equal to 3x take 5 over x plus 1, where x belongs to the real numbers and x does not equal -1. Part A says find the inverse of f of x. So let's start that down here for part A. So I might just start off by writing f of x, so I just basically don't have to keep looking up to the top of the page all the time. So this is 3x take 5 over x plus 1. Now when you're looking for the inverse of a function, it's generally a good idea to let some variable equal f of x. It's going to make it just a little bit easier to rearrange. So we can say let y equal 3x take 5 over x plus 1. And then what we want to do is to rearrange this so that x becomes the subject. So we have x by itself on the left-hand side. So we can start that off by multiplying by x plus 1 on the left-hand side. So therefore we'll have y multiplied by x plus 1 equals 3x take 5. And then expand the brackets. So therefore we have y multiplied by x plus y equals 3x take 5. And then we want to combine all of the x's together. So I'll bring that 3x over to the left-hand side and take the y from the right-hand side. So therefore we'll have yx take 3x equals negative 5 take y. And then on the left-hand side I have yx take 3x. I can factorize the x out of those terms. So we'll have x multiplied by y take 3 equals negative 5 take y. And now you can see if I divide by y take 3 on the right hand side, I'll be left with x by itself on the left hand side. So therefore x equals negative 5 take y over y take 3. Okay, so now we've rearranged this function so that x is the subject. So now what we do is we take this equation and essentially replace these variables with the inverse of f of x and x. Because the idea of an inverse function is we take what was the input, that becomes the output. So the output is now the inverse of f of x, just replacing that x with this, and the y becomes the input, or x. So this is going to be the inverse of f of x equals minus 5 take x over x take 3. And you also need to include the domain, so x is belonging to the real numbers, but x could not equal 3 here because then we get 0. So x does not equal 3. Now you could also get a different, if you did this algebra slightly differently, you might get 5 plus x over 3 take x, which is just multiplying this expression by negative 1 over negative 1. So if you did that, so let me show you what I mean. If I multiplied this by negative 1 over negative 1, I would get, well, all of these signs, they change to positive, so this would be x plus 5. And then on the bottom line, this negative 3 would become a positive 3, and the x would become a negative x. So again, this still holds, x can't be 3, this would be 0. But they're equivalent. All I've done is multiplied it by negative 1 over 1. So whichever one of those you ended up with, you should still have the right answer. So hopefully that made sense as to how you're finding inverse function. Part B says show that f of x equals x plus a over x take 1, where a is an integer to be found. Alright, here we need to find the composite function f of x. So we need to take this function and input it into itself. So let's go ahead and start B down here. So I might just start off by writing this out again. Just so I don't have to keep looking up the page all the time. So this is 3x take 5 over x plus 1. So therefore f of x is going to be this substituted into itself where there is an x term. So this is going to be 3 multiplied by 3x take 5 over x plus 1 take 5 divided by 3x take 5 over x plus 1 plus 1. So you can see this is going to get fairly messy, but hopefully it simplifies out quite nicely. Alright, so looking at this numerator and denominator here, we have separate terms. What I want is to combine those. So because I have a fraction, I need to multiply this by the denominator, and then I can combine them together to get rid of this negative 5 and plus 1 here. So this is going to be 9x take 15 if I expand that 3 across the numerator. And then I need to subtract 5 multiplied by x plus 1. And then I can write that as a single fraction all over the denominator x plus 1. And then I need to do the bottom line as well. This is going to be x plus 1 over x plus 1. So this is going to become 3x take 5 plus x plus 1 all over x plus 1. So I've just combined those numerator and denominator terms together as you would when you have two separate fractions. Okay, so now we have two fractions on top of each other with the same denominator. And when you have fractions like that with the same denominator, you can cancel that out. So this just becomes 9x take 15, subtract 5x take 5 if I expand that negative 5 to both terms in those brackets. And this is going to be all over 3x take 5 plus x plus 1. Alright, so we've simplified quite a bit now. Let's see if we can simplify further. 9x take 5x, that's 4x. Negative 15 take 5, that's negative 20. On the bottom line, I've got 3x plus x, that'll be 4x. And then negative 5 plus 1, that'll be negative 4. If I factorize a 4 out of the top and bottom line, well, this will be 20 divided by 4 is 5. So on the numerator, I'll be left with x take 5. In the denominator, I'll be left with x take 1. Okay, so I think that's in the form they were looking for. Let's go back to the question. They were looking for it in the form x plus a over x take 1. Well, in this case, a is a negative number, and that's fine. Just because it says positive in the question doesn't mean it can't be a negative number. I think that's in the form we're looking for. So we can go ahead and stop there. X take 5 over x take 1. Therefore, a is negative 5. And remember to write the domain again. X belonging to the real numbers. And x cannot equal 1 because then we get 0. Part C says the function g is defined by g of x equals x squared take 3x, where x is between 0 and 5. And it says find the value of f g of 2. Okay, so we're still talking about this function as well. And then we need to input g of 2 into f of x. So first we'll have to work out g of 2. So let's go ahead and write some of this down here. Let's write g of x down. So this is x squared take 3x. So g of 2, if we input 2 into this, that would be 4 take 6 would be negative 2. So therefore f g of 2 would be f of x with a negative 2 in it. So this is 3 times negative 2, take 5, all over negative 2 plus 1. And then we just need to go ahead and work that out. So this is going to be negative 5 take 5, which is negative 11, over negative 1. And that's going to be positive 11. So f g of 2 is 11. Part D says find the range of g. So let's have a look carefully at g. So it's not super easy to tell what the range is when the quadratic is in this form, x squared take 3x. But we can put it into a form where it's slightly easier to read off the range. So if we do completing the square on this, we could write it as x take 3 on 2 all squared, because we half that coefficient of x. That becomes the second term in the brackets. And then we haven't quite finished here. If we expanded this out again, we'd get negative 3x as the coefficient of x, but then we'd also get the 3 on 2 times 3 on 2, which would be 9 on 4. So we need to subtract a 9 on 4 to make those two expressions equivalent. It's slightly easier to read the range when the quadratic is in this form, because this straight away tells you what the minimum or maximum is just by reading these points here. Well, I know it's a minimum because this is a positive quadratic. So the x value of the minimum is 3 on 2. So I can say min equals 3 on 2, and the y value is negative 9 on 4. Okay, so that tells me the minimum of this quadratic. And remember, the domain is x between 0 and 5. So therefore the x values only go up to 5. Now I know this minimum is in the range because the x value for the minimum is 3 on 2. That is between 0 and 5. But we should also work out what g of x is when x equals 5. So g of 5. If we substituted 5 into this, we'd get 25 take 15. That would be 10. So the maximum y value is 10. The minimum is negative 9 on 4. So therefore we know the range. So we can say the range will be negative 9 on 4. And g of x is greater than or equal to that. And then it's less than 10. Less than or equal to 10. And that's for the domain where x is between 0 and 5. Okay, so that's the range. And then part E says explain why the function g does not have an inverse. Okay, well, technically you could find an inverse for this, but you'd have to break it up by restricting the domain. The reason you can't find an inverse is because it's not a one-to-one function. So essentially you couldn't reverse this and say, well, what x value would I get for if I put a y value in? Because you'd get two answers. So we can just say g of x is not one-to-one. So it has no inverse. All right, that was question 10 for a total of 13 marks. Let's go back and look at the marks again. A was 3, B was 4, C was 2, D was 3, and E was 1. Question 11 gives us a graph and it says figure 5 shows a sketch of the curve C with equation y equals f of x. The curve C crosses the x-axis at the origin O and the points A and B as shown in figure 5. Given that f dash x equals k take 4x take 3x squared, where k is constant, part A says show that C has a point of inflection at x equals negative 2 on 3. Okay, so it's important to understand what a point of inflection is. So if you've got a graph like this, the point of inflection will be where the gradient goes from increasing to decreasing and vice versa. So if you look at the tangent, say at this point here on the curve, and then at this point here, okay, it's going to be a little bit tricky. So this tangent would have some slope, let's say it was 2. This slope is clearly steeper, so let's say this slope was 3. So at this point in the curve, before this inflection point, the gradient is increasing. After the inflection point, let's look at this point here. So let's say the gradient got up to 3 or 4 or whatever. After the inflection point, it starts decreasing. So this slope here, you can see is less steep than the last one I drew. Maybe this one is 1 or 2 or something again. So hopefully that makes sense. The point of inflection is where the gradient stops increasing and starts decreasing and vice versa. You can also go the other way. So how can we express that point of inflection using calculus? Remember, the second derivative is the change in the gradient. So if the second derivative is positive, that means the gradient is increasing. If the second derivative is negative, that means the gradient is decreasing. And if the second derivative is 0, that means the gradient is neither increasing nor decreasing. And that's what happens at the inflection point. The gradient is kind of balanced between increasing and decreasing. So we can find the second derivative. When that equals 0, that is an inflection point. So let's start off down here by stating we understand what a point of inflection is. So the point of inflection when the second derivative equals 0, or when the gradient is neither increasing nor decreasing. So let's go ahead and find the second derivative of f of x. So if f dash x equals k take 4x take 3x squared, k is a constant, so that will disappear. We'll be left with negative 4, and use the power rule, that will become negative 6, 3 times 2, and then take 1 away from the power, so we'll be left with negative 4 take 6x. And we're trying to show that x equals negative 2 on 3 is a point of inflection, so we can substitute that in to the second derivative. x equals negative 2 on 3. The second derivative will be negative 4 take 6 times negative 2 on 3. What does this equal? Well, this will be, 6 divided by 3 is 2. 2 times negative 2 is negative 4. But we're subtracting this, so this will be 2 negatives make a positive. So this will be negative 4 plus 4, and that equals 0. So we can say, therefore, there must be a point of inflection at negative 2, 3. At x equals negative 2 on 3. Okay, so that was part A. Part B says, given also that the distance AB equals 4 root 2, find showing your work in the integer value of k. All right, so we've got this length here, AB. They've said is 4 root 2. They've also told us that A and B are where the curve cuts the x-axis, or in other words, A and B are the solutions to f of x. So that's going to help us. But firstly, what we want is the function of this curve. So we have the derivative, but what we want to do is take the antiderivative and get the function of the curve itself. So that's what I'd start off with, taking the antiderivative of f dash x. So for part B, let's start that down here. F of x is going to be the antiderivative of this. So this becomes, k is just some constant, so that will become kx. Negative 4x, well, we use the power rule, we add 1 to the power, so that will become x squared, and then divide by that power. So this will be negative 4 divided by 2, will be negative 2 x squared. And then do the same thing for the last term. This will become x cubed, and then divide by that power, divide by 3. 3 divided by 3 would just be negative 1, so we'd be left with negative x cubed on the end. Okay, so as I said, we've got kx, take 2x squared, take x cubed, and then we need to plus some constant on the end. However, we know that one solution is 0, 0 because they tell us that the curve crosses the x-axis at the origin, which is 0, 0. So that is one solution to this function. So using that idea, let's write that down. One solution equals 0, 0. If we substitute that into f of x, that means f of x equals 0 and x equals 0. We'd have 0 equal to 0 take 0 take 0 plus c. What does that mean? C must equal 0, right? So therefore we can say f of x equals kx take 2x squared take x cubed, because we've figured out that constant is just 0, so you don't have to worry about it anymore. Okay, so what am I really looking for here to help me solve for k? Well, I'm looking for the coordinates of a and b, right? If I can find a and b, they will tell me what k is. So how do we do this with the cubic function? We set it equal to 0 and we try to solve for x. So that's what I'm going to try to do here. So at points a and b, this function is going to equal 0, and I might just write it slightly differently. So minus x cubed take 2x squared plus kx. So I have that x cubed term out the front. This is going to equal 0. And I could also factorize an x term out of all of these. So this could be, and I might make it a negative x term, so I get rid of this negative out the front. So this will be a negative x multiplied by x squared plus 2x take k equals 0. All right, so now I know what I already know, that x equals 0 is a solution, right? That's what that x out the front is telling me. X should be 0. Also, this quadratic in here could be 0. So therefore, x squared plus 2x take k could equal 0. And I can't factorize this because I don't know what k is. It might be a whole number, it might not be. And actually you could guess and you could try to factorize. So what is an integer that when you factorize it makes plus 2, and see if that works out with your solution. But we also know that whatever the two solutions are to this quadratic, they need to have a distance between them of 4 root 2. So the distance between a and b is 4 root 2. So that's going to help us find k. So I can't factorize this quadratic, therefore I need to use the quadratic formula. So that says that x equals negative b plus or minus the square root of b squared take 4ac over 2a. And then take the coefficients, plug them in. So b is 2, so this is going to be negative 2 plus or minus 4, take 4 times a, which is just 1, and c, which is k, or actually negative k. Okay, and that is all over 2a, or just 2. So let's try to simplify this a little bit. If I separated this into kind of two parts, this would be negative 2 on 2, which is just negative 1. And then I've got plus or minus the square root of 4 take 4 times minus k. So that's going to turn into a plus or a positive term. This will be 4 plus 4k all over 2. Now looking at this term here, I could factorize a 4 out of the terms inside the square root. So I'll just explain what I'm doing over here. So this could be written as 4 times 1 plus k in brackets. And we know that the square root of ab can be written as the square root of a multiplied by the square root of b. So using that idea, I could write this as the square root of 4 times the square root of 1 plus k, which would just be 2 multiplied by the square root of 1 plus k. Okay, so using that idea, this here would evaluate to 2 root 1 plus k on the numerator, and then that 2 would cancel out with the 2 in the denominator. So this could be written as negative 1 plus or minus the square root of 1 plus k. Okay, so I have a simplified expression for the values of x. And again, just to reiterate, I know that the distance between those terms needs to be 4 root 2. So what I could do is take these two solutions, the positive and the negative one, find the difference between them, set that equal to 4 root 2, and see if I can come up with some value of k. So let's say, therefore, negative 1 plus the square root of 1 plus k, take negative 1 take the square root of 1 plus k. That difference needs to equal 4 root 2. So let's see if we can simplify this somehow. So this is going to be negative 1 plus the square root of 1 plus k, take negative 1, which is plus 1, take negative root 1 plus k, which is plus the square root of 1 plus k, equals 4 root 2. Negative 1 plus 1, they will cancel out. Then we'll just be left with 2 lots of the square root of 1 plus k, equals 4 root 2. And if I divide by 2, I'll be left with the square root of 1 plus k equals 2 root 2. Another way of writing 2 root 2, well, this could also be written as the square root of 4 times the square root of 2, right? So, which could also be written as the square root of 8, right, using this same law up here. So therefore, I know that the square root of 1 plus k equals the square root of 8. So 1 plus k equals 8, therefore k equals 7. Right, so 1 plus k equals 8, so therefore k equals 7. So we finally got there in the end, and I hope that process kind of made a bit of sense. That was question 11 for a total of 10 marks. Let me reiterate a little bit the steps I went through. So we took the antiderivative to find f of x. We said that c must be 0 because it passes through 0, 0. And then we said at a and b, this function must equal 0. We tried to find those solutions, and we said the difference between those solutions was 4 root 2, therefore k must be 7. Question 12 says, show that the integral from 0 to pi on 2 of sine 2 theta over 1 plus cosine of theta with respect to theta equals 2, take 2 log 2. And this is for 7 marks. I'm just going to focus on the integration, and I'm going to ignore these 0 and pi on 2 to start with. So let's just talk about the integral of the sine of 2 theta over 1 plus the cosine of theta with respect to theta. Now the first thing is, I don't want these two variables being different. I don't want 2 theta and theta because I'm taking the derivative with respect to theta. So I want to use the double angle formula to get rid of this 2 theta here. So this is going to equal the integral of 2 sine theta cosine theta over 1 plus cosine of theta. So remember the double angle formula says sine of 2 theta equals 2 sine theta cosine theta. Now I might write this slightly differently. I'm not actually doing anything to the expression. I'm just trying to make it slightly clearer for myself to potentially see a solution. So I'm going to remove the constant 2 and then separate this into two fractions. So this will be sine theta cosine theta multiplied by 1 over 1 plus the cosine of theta with respect to theta. Okay, so now we need to use substitution. So we're going to have to let one of these things equal a variable, take the derivative of that, and then hopefully when we substitute it in, it all neatens up into an expression we can take the integral of. So let's say we let u equal to the cosine of theta. Now you could do it the other way with sine of theta and see what happens. And you might find it works, you might find it doesn't work. But here, because I've got a cosine of theta in the numerator and denominator, I want to substitute something in for that rather than the sine theta, which I only have in the numerator. So if u equals the cosine of theta, that means the derivative of u with respect to theta equals negative sine theta. That's the derivative of the cosine. Then you can rearrange this equation in terms of d theta, and that will allow you to substitute in for this d theta in this expression here. So if we have this du on d theta equals negative sine theta, we can say d theta equals du on negative sine theta. Okay, let's substitute all of that into this expression. Let's see what happens. So this is going to be 2 times the integral of, we still have that sine theta there. When we get to cosine of theta, substitute in u. And then we've got 1 over 1 plus u. And then when we get to this d theta, substitute in du over negative sine theta. Okay. Now we have a sine theta in the numerator and denominator. They will cancel out. And we'll just be left with a negative 1. So this is going to equal 2 multiplied by the integral of u over 1 plus u. And it's also a negative, and this is with respect to u. Okay, so now we have an integral we can actually do, almost. So firstly I might remove that negative here, so it's going to be a negative 2 now as the constant out the front. And u over 1 plus u, that can be written as 1 take 1 on u plus 1. So let me just show you what I mean. So let's say we had x over x plus 1. This could be rewritten as x plus 1 take 1, right? So I haven't done anything to that numerator. All I've done is added 1 and then taken 1 away. So I haven't changed anything. And then this could be written as x plus 1 over x plus 1, right? Separating these bits here. And if I separate those brackets, it'll be x plus 1 over x plus 1 take 1 over x plus 1. Okay, and this will become 1, right? X plus 1 over x plus 1 is just 1. So this can be written here, u over 1 plus u can be rewritten as 1 take 1 over u plus 1. Plus 1 plus u, same thing as u plus 1. And this is with respect to du. Okay. Why have I done all that? Well, I know the integral of 1 is just u, and the integral of 1 over u plus 1, well, if you know the integral of 1 over x is the log of x, then you also know the integral of 1 over u plus 1. It's just the log of u plus 1. Okay, and then we just need to add c on the end. Okay, so I might expand these brackets with this -2, so this will be -2u plus 2 log of u plus 1 plus c. And I might leave it in that form for now before I substitute in the cosine of theta back into it. Okay, so now let's have a look at the interval. So we're going from 0 to pi on 2 of all of this. So let's write out what that's going to be. So this is going to be 0 to pi on 2 of sine 2 theta over 1 plus the cosine of theta with respect to theta. This is going to be when we substitute pi on 2 into this, take when we substitute 0 in. So this is going to be this integral here, -2u plus 2 log of u plus 1 from 0 to pi on 2. All right, now we're going to have to bring that cosine of theta back in. So this is going to be pi on 2, substituted into this, will be -2 times cosine of pi on 2 plus 2 log of cosine of pi on 2 plus 1. And then substitute 0 in and subtract them. So this will be -2 times the cosine of 0 plus 2 times the log of the cosine of 0 plus 1. All right, so what does this evaluate to? Well, the cosine of pi on 2 is 0, right? Remember, think of your unit circle, the cosine at pi on 2 here. If you think of the cosine as the x value, that's 0. The cosine at 0 is 1. That's 1 there. So this should hopefully evaluate something fairly simple. -2 times 0, well, that will cancel out. This will be 2 times the log of 1. So let's just write that in. This will be 2 times the log of 1. 0 plus 1 is just 1. And then this is subtract -2 times the cosine of 0 was 1. So this will be -2 plus 2 times the log of 1 plus 1, which is 2. Okay, we'll have to go on to the next page now. The log of 1 is 0. So that's something you should know, or you can always just put it into your calculator and check. So this first term cancels out. Then we have negative times -2 plus 2 log of 2. And then expand that negative to both terms. We'll have 2 take the log of 2. And that's about as simple as we can get. Let's just check that's what they were looking for. 2 take 2 log 2. Looks good. And then we are done with question 12 for 7 marks. Question 13, part A says express 2 sine theta, take 1.5 cosine theta in the form r sine theta take alpha, where r is greater than 0 and alpha is between 0 and pi on 2. State the value of r and give the value of alpha to 4 decimal places. Okay, so this is a fairly common question in A levels, and the usefulness of it is actually demonstrated in this question. So I won't go into that now, but let's have a look at A. I might start it down here. So we're looking to change an expression in this form, a sine theta take b cosine theta, into the form r sine theta take alpha. And we know a equals 2 and b equals 1.5. So the way we find alpha is to say that tan theta equals b on a. So therefore, the tan of alpha is 3 on 2 over 2, which is just 3 on 4. So then we need to find the inverse of 3 on 4, the inverse tangent of 3 on 4, or the arctan of 3 on 4, to get alpha. Okay, so let's put that into a calculator. Inverse tangent of 3 on 4. And we get 0.6435. Okay, so we've got alpha. The way we find r is to take the square root of a squared plus b squared. So therefore r equals the square root of 2 squared plus 1.5 squared. And we could just put that straight into a calculator, save some time. So 2 squared plus 1.5 squared equals 2.5. So therefore we can say 2 sine theta take 1.5 cosine theta equals 2.5 sine theta take 0.6435. Okay, so that's part A. Part B says Tom models the depth of water D meters at Southview Harbour on the 18th of October 2017 by the formula D equals 6 plus 2 sine 4 pi t on 25 take 1.5 cosine 4 pi t on 25, where t is between 0 and 24, where t is the time in hours after midnight on the 18th of October 2017, so 0000 hours. Use Tom's model to find the depth of water at midnight on the 18th of October 2017. Okay, so as t is the time in hours after 0000, then for part B, t is just going to equal 0. So let's do part B down here. So when t equals 0, d is going to equal 6 plus 2 sine of 0. If t equals 0, then everything in those brackets will be 0. Take 1.5 of cosine of 0. The sine of 0 is 0, so that term will cancel itself out. The cosine of 0 is 1, so this will just be 6 take 1.5, which is going to be 4.5 meters at midnight on the 18th of October. Okay, part C says find the maximum depth of water, and this is where we see the usefulness of writing it in this form, r sine theta take alpha. So for part C, if you were to try to find the maximum of the depth using this formula, it's kind of complicated. You don't really know how to maximize it. You know, sine could be 1 and cosine can be 0, but would that give you the maximum depth? It's not 100% clear. Oh, sorry, I'm looking at the wrong one. We're looking at this one up here. So it's much easier to say, oh, the maximum depth will be when sine theta equals 0, when you only have one trigonometric function there. So let's go ahead and start on part C, and I'm going to write the depth as the formula we worked out in part A. So we worked out that this part here, 2 sine theta take 1.5 cosine theta, could be written as 2.5 sine theta take 0.6435. So this is going to be 6 plus 2.5 sine theta take 0.6435. But theta is not just theta, is it? We've been given an angle. It's 4 pi t on 25 take 0.6435. Okay, so that's another way of writing that expression for the depth. And we'll have the maximum depth when the sine function is at its maximum value. What's the maximum value of a sine function? It's 1. So we can say the max depth when sine of x, whatever x is, equals 1. So then d will equal 6 plus 2.5 times 1, which is just 2.5. So I should have written d max will equal 8.5 meters. Okay, much easier when it's in this form. So therefore, the question's already shown the usefulness of writing a function in that way. Okay, so that was part C. Part D says find the time in the afternoon when the maximum depth of water occurs. Give your answer to the nearest minute. Okay, so we've said the maximum depth occurs when sine of this equals 1. So we could use that fact again in part D. So let's state that again, just to show we know what we're doing. So the max depth when the sine of all of this, 4 pi t on 25 take 0.6435 equals 1. So therefore, what will this equal? When does the sine of an angle equal 1? Well, when all of this equals pi on 2. That's when the sine function equals 1. So we can say therefore 4 pi t on 25, take 0.6435 equals pi on 2. However, it's not just pi on 2, it also has a period, right? So the next maximum will occur after the period of the sine wave has reached its maximum again. What's the period of the sine curve? It's 2 pi. So this is going to be plus 2 pi, and this will actually keep on going for every 2 pi after that. So we can say plus 2 pi k. And I'm going to include that step. However, we also know that the time is between 0 and 24. So there probably won't be another maximum in that time period, but it's always good to indicate you know that the sine curve keeps on going and there will be further maximums after pi on 2 plus 2 pi. So we have an equation and we can go ahead and solve this for t. So firstly, what we could do is to add this negative 0.6435 over to the other side. So 4 pi t on 25 equals pi on 2 plus 2 pi times k, and I should say k is a integer value, so that can be 1, 2, 3, etc. Can't be I'm not talking about decimals or fractions. So this was plus 0.6435. Okay, and then we can multiply all of that by 25 and then divide by 4 pi to get t. So this is going to be 25 times pi on 2 plus 2 pi k plus 0.6435 divided by 4 pi. Okay, so luckily we have a calculator to do all of that for us. So this is going to be, the first t value will be just pi on 2 plus 0.6435. So this is 25 times pi on 2 plus 0.6435. And I might just find that and then divide by 4 pi. If you have a fraction button on your calculator, that might come in handy at this point. So for the first t value, get 4.405. That's clearly not in the afternoon. So I'm going to write it down, but I'm not going to bother with it too much. Then I want to find the next one. So this is going to be 2 pi plus pi on 2, which is going to be 5 pi on 2. So I'm going to do 25 multiplied by 5 pi on 2 plus 0.6435, and then divide that by 4 pi. And I get 16.905, and that is in the afternoon. So 16 in 24-hour time, that would be 4 p.m. around about, plus some minutes. So 16.9052 is my next value. And then I need to convert that 0.9052 into minutes. So in the afternoon, we'll have 16, and how many minutes? 0.9052 times 60 should give us the minutes, and that's 54. I'm pretty sure the question said to the nearest minute. Let me just double check that. Give your answer to the nearest minute. Yep, so this is going to round off to 16:54 p.m. So that's when we get a maximum depth in the afternoon, and there's also one obviously in the morning around 4 a.m. Okay, so just double check I answered everything in that question. Okay, so give your answer to the nearest minute. Yes. All right, so part E says Tom's model is supported by measurements of D taken at regular intervals on the 18th of October 2017. Jolene attempts to use a similar model in order to model the depth of water at Southview Harbour on the 19th of October 2017. Jolene models the depth of water h meters at Southview Harbour on the 19th of October 2017 by the formula h equals 6 plus 2 sine 4 pi x on 25. Take 1.5 cosine 4 pi x on 25, where x is between 0 and 24. So you can see she's just taken Tom's model and replaced t with x, and she's measuring it at the same place, Southview Harbour. So where x is the time in hours after midnight on the 19th of October. And the question says, by considering the depth of water at midnight, 19th of October 2017 for both models, explain why Jolene's model is not correct. Okay, so according to Tom's model, on the 19th of October at midnight, T will equal 24, right? So he started on the 18th of October at midnight, he's gone 24 hours, T would equal 24. So would we still have the same model? Well, no, we wouldn't. If we put 24 into this, we would have 24 times 4, which is 96 pi on 25, which is different to 4 pi on 25. One way we can state this is to say that they're not continuous. So if she starts at 0, 0 on the 19th of October, this is not going to be continuous with Tom's model. So EI, I'm going to say something along those lines. So I'll say according to Tom's model, T equals 24 on the 19th at 0, 0. Therefore, the models are not continuous. Okay. Now you could go ahead and find the depth at each one. I mean, to me, it's clear they're going to be different. So I'm not sure that's really necessary. Also, you can mention the period. The period of Tom's model is going to be, well, one way to find the period is to do 2 pi divided by the coefficient of the variable. So here it would be, let me just write this out, period equals 2 pi on b, where b is the coefficient of t here. So it would be 2 pi on 4 pi on 25. And that evaluates to 12.5, right? 25 divided by 2 essentially. And that's not going to be repeating at 24 hours. So you could also use the period to reinforce your argument. But yeah, honestly, I think it's quite clear. However, perhaps they want more detail in this answer. So I'd suggest, if you think this answer is not detailed enough, maybe look at the mark scheme and kind of come up with your own ideas there. But I think it's just clear that at t equals 24, they're not the same. So she can't just continue at midnight on the 19th. So for part 2, the question is asking, hence find a suitable model for h in terms of x. Well, if x is going to be the variable for Jolene's model, and we're using the same model, t starts at 0, 0 on the 18th, we could just say x plus 24 in here. We could just substitute that into this model. I guess that's probably the simplest way of doing it. So we could say this is going to be h equals 6 plus 2 sine 4 pi multiplied by x plus 24 all over 25. Take 1.5 cosine of all of that as well. So that would guarantee if x is going to be 0, 0 on the 19th, we need to add 24 to it for the model to be consistent. Okay, so that was question 13, for a total of 11 marks. A was 3, B was 1, C was 1, D was 3, and E was 3. Question 14 gives us a graph and it says figure 6 shows a sketch of the curve C with parametric equations x equals 4 cosine of t plus pi and 6, y equals 2 sine t, where t is between 0 and 2 pi. Show that a Cartesian equation of C can be written in the form x plus y all squared plus ay squared equals b, where a and b are integers to be found. Okay, so notice it says curve. But what sort of curve does this look like? It looks like an ellipse, right? An ellipse is, essentially a stretched out circle or an oval. So it looks like an ellipse. And one thing we know about the parametric equations of an ellipse are that they are x equals a cosine t and y equals the sine of t. So we've almost got that here. We could almost say this is an ellipse, but we haven't got the same angle. So let me just state my thinking so far. So an ellipse centered at 0, 0, that's important. If it's not at 0, 0, then the equations change a little bit. has parametric equations x equal to a cosine t and y equals b sine of t. So that's where the angles or the variable t is the same and the coefficients can be different. So here we have different variables inside the functions. So my thinking is, if I can do something to this function, this x function, to change this variable so that it is the same as the y function, then I'll be able to say this is an ellipse, and therefore I also know the Cartesian equation of an ellipse, the generalized form of that. So I'm going to use the sum of the angles formula for this one here, for the 4 cosine t plus pi on 6, and see if it comes out to something that I can work with. So I know the sum of the angles of the cosine of t plus pi on 6. I can look the formula up in my formula booklet. This is going to be 4 multiplied by the cosine of t times the cosine of pi on 6. Take the sine of t multiplied by the sine of pi on 6. So that's part of the sum and difference formulas for trigonometric functions. So let's have a look at this now and see if we can simplify it at all. So this is going to be 4 multiplied by the cosine of t. Now the cosine of pi on 6, you need to know the absolute value of, and you can remember those using these triangles. Now there's a triangle for pi on 2, and there's a triangle for pi on 6 and pi on 3, which is the other angle in this triangle. So this is a right angle triangle, and the sides are 1, 2, and root 3. So the cosine of pi on 6 is the adjacent side over the hypotenuse. So that's going to be root 3 on 2. Take the sine of t multiplied by the sine of pi on 6. The sine of pi on 6 is the opposite side over the hypotenuse, which is 1/2. And then let's see if we can simplify this any further. If I expand that 4 out to both terms, this will be 4 divided by 2, which will just be 2 root 3 cosine t. Take 4 times 1/2 is 2, so this will be take 2 sine of t. And now you might notice something. Go back to the original equations. Y equals 2 sine of t. So here in this expression, we have y, right? So right here is the function for y. And remember, all of this was the function for x. So we can say x equals 2 root 3 cosine of t take y. So therefore, x plus y equals 2 root 3 cosine t. Now here's the really tricky part. We're going to let u equal x plus y. So therefore, u equals 2 root 3 cosine t. And y equals 2 sine of t. So these two equations would form an ellipse. Just as we said, it would be centered at 0, 0, and it has the parametric equations a cosine t, b sine t, right? So we have an ellipse with u and y. Now we can talk about the Cartesian equation for an ellipse. So the Cartesian equation of an ellipse centered at 0, 0 is x squared on a squared plus y squared on b squared equals 1. So that's the general form of the equation of ellipse. And this a and b comes from these parametric equations. This is the a, this is the b. So therefore we can say this will be x squared over a, which was 2 root 3. So this is going to be 2 root 3 all squared, plus y squared on b, which was 2. So this will be 2 squared equals 1. Except my x here is not x, it's actually u. Okay, so rather than putting x, I'll say u squared. All right, so therefore u squared over 2 root 3 all squared, that would be 4 times 3, that would be 12, plus y squared over 4 equals 1. And now go back to the value of u we had. We let u equal x plus y. So substitute that back in now. Therefore, we'll have x plus y squared. And then multiply by 12. So if we multiply the first term by 12, we'll just be left with x plus y all squared. Multiply the second term by 12. 12 divided by 4 is 3. So we'll have plus 3y squared. And then this 1 times 12 will become 12. And then we have it in the form that we're looking for. X plus y squared plus 3y squared equals 12. And where a is 3 and b is 12. Okay, so we can just state that a equals 3, b equals 12. And then we're done for the last question on this paper. And that was for 5 marks. Total marks in this paper was 100 marks. And I hope you found that useful. Leave a like if you did. Subscribe if you want to see more content. Let me know. I know that some of you were saying you want to see more further maths content and more A-level content, and I'm trying to get around to that. But I'm going to finish with these 3 sets of papers first and then hopefully get on to some of that. But other than that, let me know what you want to see. If there's anything in this paper that could be improved or any mistakes I made, please let me know. Other than that, I'll see you in the next one. Bye for now.